Alright, so we're starting on the side that says Mr. Wallen is talking about his fence here. It says that he has 100 yards of fence he can put up, and he wants to form a rectangular field enclosed on 3 sides. So rectangular, 3 sides by the fence, and 1 side by a river. So here's our river. Find the greatest area the fence can enclose. And you did have a way in Algebra 2 to solve this thing, but now you've got more tools in your pocket. You've got some other things you can do to solve this. So we're going to use some derivatives today. Now, if we're talking about area of a rectangular field, how do you find that? How do you find area? Length times width, right? For a rectangle. I don't know this length, so I'm going to call it x. And I'm going to call that y. If this distance right here is x, how long is this side? Also x. So I know area is supposed to be x times y. Is there another equation we can make based on the information we know here? Well, we could rearrange the equation we have. That is one thing we could do. We're going to do that in just a second. But don't we also know something about this 100 yards of fence? Isn't it true that this distance right here has to be exactly 100? So I know that 2x's plus y has to equal exactly 100 yards. I do know that. Now it would be handy if I could turn these into like one equation, so we're not like trying to do 2 things at once. So I'm going to subtract 2x from both sides to get y by itself. And because this is our notes, I'm going to kind of draw a little picture here so I don't forget what happened. I'm going to take that and I'm going to plug it in right there. So instead of a equals x times y, I have a equals x times 100 minus 2x. And now it's kind of 2 equations in one, which is pretty handy. Now it's asking about the greatest area, the maximum area that fence can enclose. When you're looking for local maxes or local mins, what do we use to do that? First derivative test, right? Which means we kind of need a derivative. I don't really want to do product rule on this because sometimes that takes more thought, so I'm going to distribute first. You don't have to, but I'm going to. So that I don't have to think so hard when I take the derivative. So that I have 100 minus 4x. There's our derivative. How do I get to that number test line? What do I need to do? Set equal to 0. That's what we've been doing. Okay. So we subtract 100 from both sides. Divide both sides by -4. And we get x is 25. So if we do our little derivative number line test on the bottom right hand corner. What numbers go on this thing? 25, there's a critical number. Now, can x really be anything less than 25? No. What's the lowest it could be? 0 really is the lowest, right? Like, I mean, it can't be exactly 0, but it could be like 0.0001. And what's the largest x could be? 100 or 50? There you go. How come 50? Yeah, because it's half, because we have 2 of them here. So if the total is 100, then these could each be almost 50. So let's figure out what's happening here when we plug in these numbers. If I plug in, say, 10 into the derivative, do I get a positive or a negative? A positive. If I plug in like 30, I get a negative, right? So if I am increasing and then decreasing, what does that tell me about what happens at 25? That's the max. So I know that at 25 comma something, I've got a maximum point. They don't want that though. They want the greatest area. Well, I know that our greatest area happens when x equals 25. So can't I just plug in 25 right there? Sure. So area equals 25 times, wait a minute, I don't have a y. Plug it in the other equation. So if I put in 25 right here, I should be able to get y, which is 50. Everybody see how I got that? I replaced x with 25, and now I got y equals 50. So a equals x times y. And 25 times 50 is 1,250. What's my label? Yards squared. Good. So that's your greatest maximum, greatest area the fence can enclose. Questions on how we did that? Okay, same kind of problem on the next one. Find two positive numbers whose sum is 8. So I'm thinking one number plus another number is supposed to be 8. They also say that they're positive. So I'm thinking x is going to have to be between 0 and 8, right? And y would also have to be between 0 and 8. Doesn't that make sense? If you add them together and you get 8, that's kind of the only way to do that if they're both positive. And whose product, so the first number times the second number equals some sort of product. And that product, I want it to be the biggest product I can have. Again, I've got two equations. I kind of just want one. So I'm going to turn the top one into y equals 8 minus x. And I'm going to take that and I'm going to stick it in for that y right there. So instead of x times y, I have x times 8 minus x. I'm going to distribute. Okay, I need a maximum product. What do I do? Derivative, yeah, I heard it. So the derivative is going to be 8 minus 2x. And if I'm looking for a maximum, I'm looking for a local max. We need a number line. In order to make that number line thing work, we need to set it equal to 0. So we set it equal to 0 and solve. So x could be 0, 4, or 8. If I plug in, say, like a 2 into the derivative, do I get a positive or a negative? Positive. If I plug in like a 6, I get a negative. So that's telling me we're increasing and then we're decreasing, so this must be our maximum number. If x is 4, what's y? 4, yeah, because up here. Now that I know what those are, I can say x times y equals the maximum product, which is 16. But they say to find the two positive numbers, so we did, 4 and 4. You always want to make sure that you read the question and you're answering the actual question. On this one, they wanted the two positive numbers. On the top one, we could have found length and width. We did. They didn't ask for that. They just wanted the greatest area the fence could enclose. Backside, last one. It says to make an open top cardboard by cutting squares from each corner of a 12 by 15 inch piece of cardboard, and you fold up the sides. And you guys probably know this, but in case you didn't, you have a rectangle, and if you cut squares out of the corners, and then you fold up all these little guys, like along the dotted lines, you get a rectangle. You get a box that's open on the top. You guys know that, right? So this is a 12 by 15 inch piece of cardboard. How much did we cut off? We don't know, but we need to maximize the volume, right? I do know that I cut off a square. So I don't know how far in I cut or how far over I cut, but I know that those are the same length, right? Because it's a square. So there's an X, there's an X, there's X, there's X, there's X, there's X. Right here, the cardboard was 15 inches long. After I fold all this stuff up, isn't it just going to go from here to here? Yeah. So it's not 15 anymore. What is it? 15 minus, what do we subtract off? 2 x's. Good. So this side of the box is 15 minus 2x, and this side would be 12 minus 2x, right? Now volume is a three-dimensional thing. I'm not really taking my time on this box, sorry. There's the inside, if you want to see it. It's not very good. But we get the idea. This would be 12 minus 2x. This would be 15 minus 2x. What's the height? Well, how far in did we cut? X, yeah. The height of the box is right there whenever you fold it up, so we have x. Now you can find volume because it's the length times the width times the height. And I did multiply all that together this morning. So to save you some time, I'll just kind of get you there. If you multiply all the stuff and FOIL it out, you get 4x cubed minus 54x squared plus 180x. They want us to find the largest possible volume, the maximum volume. What do? Derivative. So now I have 12x squared minus 108x plus 180. What's our next step? Equal to 0. At the same time, I'm going to go ahead and factor out a 12. So I get x squared minus 9x plus 15. Is that factorable? It's not. So you can do quadratic formula. When you do, I'll tell you get 9 plus n minus radical 21, all divided by 2. I did figure out what those decimals were this morning. You're going to wind up with approximately 2.209 and 6.791. There are two answers. So we do our little number line. And I've got 2.2-ish. And I've got 6.8-ish. And the smallest that x could be is almost 0. And then the largest that x could be, I don't know, let's see here. What's the largest x could be? 6. Well, technically. Let's pretend like we didn't even think about that. We could put 12 or whatever. I do want you guys to see the pluses and minuses on this. If you take like 1 and you plug it in, you're going to wind up with a positive. If you take a 5 and you plug it in, you're going to wind up with a negative. Take like a 10 and plug it in, you're going to wind up with a positive. Now what? Increasing, decreasing, increasing. So here's our maximum. That's the whole point of that test, is to tell you where the max is. We know where it is. It happens when x is about 2.2 inches is that we're dealing with. So whenever you come in about 2.2 inches, it's going to maximize the volume of your box. They want to know what the largest possible volume is, which means I'm going to need to know all of these little values here. So you've got 12 minus 2.2. Let me type that in. 12 minus 2 times 2.209. You get 7.58. I've got 15 minus 2 times 2.209. I get 10.582. And this one, of course, was 2.209. So now we can multiply them all together. So 7.58 times 2.209 times 10.582. We get 177. I'm going to call it 2 inches cubed, and that's your maximum volume. Oops, sorry. I didn't mean to do that. There you go. Any questions with kind of how to do these? Question? Because that's where it's a local minimum. We're looking for the local maximum. Well, if you were gonna, okay, so let's say you don't have a calculator to graph this to be able to look at where your maximum is. This derivative test tells you where it is, sorry. Yeah. Well, whenever we set it equal to 0, that would be a turning point, right? That's where the tangent line equals 0. So it's a turning point at this place. We just don't know if it's turning at the top or at the bottom. So that's why we do this to figure it out. Tiffany? Uh-huh. Yes, you have to do your steps. And sometimes, yeah, there'll be an issue sometimes. So, yeah, make sure you show your steps. There's your assignment on the back side. Due next time I see ya.